Hello everyone, welcome back. Now we're going to discuss chapter 5, and let's see, my teaching screen is here. Chapter 5 from the net acad, Swiss configuration. That's the title of it. Let's get into it. 5.1 basic Swiss configuration. Okay, let's get started. Swiss boot sequence. We're going to learn a few things about the switch before we learn how to configure a switch, how to configure security on a switch port, and so on. So switch's boot sequence, that is something we would like to learn first. How does the switch boot? So when we turn on the switch, we know that the first thing it will do, very first thing, switch is going to do something called post, P-O-S-T. Post mean power on self-test. Right here, see if I can show you. Okay, post. So who does the post? As soon as the switch is turned on, the motherboard of the switch, the main board of the switch gets the power, and there is something called, like in the computer PC, we have the BIOS, and that's the firmware. In the switch, Cisco router, Cisco switch, we have something called ROM, R-O-M, read-only memory. Okay, in that read-only memory, there is something, a little firmware, little program that's called ROM monitor, or and also another little program called Bootstrap. These two programs are stored in the ROM, read-only memory. So the ROM is the one is going to perform the post, power on self-test. It's going to check itself, check its processor, RAM, check the hardware. It's okay. Before I do anything, I want to make sure that the switch itself, my own hardware, is good. My processor is good, memory is good, everything's functional. That's the first step. What is the second step? Next, the switch loads the bootloader. After the post, POST, is done, then it's going to load the bootloader program. It's a program that is a limited version of the iOS, not the complete operating system. It has a limited version of the iOS that's going to load up. It helps you, this limited edition helps you if you need to configure a brand new router, load the operating system iOS onto it, then this gives you at least a command prompt, at least some way to get into the switch and start typing commands. Okay, the bootloader performs a low-level CPU initialization. I'm not going to go into that detail, but here, going right here, that the bootloader finally locates and loads an operating system. The bootloader, the bootstrap program, it loads and then looks for an operating system. Most of the time, an operating system would be located in the flash memory. In the flash memory, the Cisco iOS, just like it shows right here, that's an iOS file, like C2960, that LAN base K9, MZ, the whole thing all the way to .bin. That's a file. That's an operating system file. That is located normally in the flash memory of the router or the switch. Now, after the operating system is loaded, of course, then the very last step would be that the router or switch would look for a configuration file, the startup config, that is normally stored in the NVRAM, non-volatile RAM. So if I just summarize, and not to confuse you, summarize and repeat, first thing, number one, would be the post, P-O-S-T. Who does that? The ROM, R-O-M. ROM has the ROM software, it does it. Number two, ROM also has the Bootstrap program. The Bootstrap program is a small, short version of iOS, very limited. It's gonna load up to the RAM. Everything is loading to the RAM. Number three, the Bootstrap program now is going to look for the operating system. Normally, it is found in the flash memory. If it is not, then you got to load it to the flash from somewhere or from a TFTP server. I'm not going into that detail, going into that direction at this time. But say an operating system is found in the flash, and the operating system loads up also to the RAM. Now operating system is loaded. Next, the router is going to look for the configuration file where you have configured the password, configured the IP addresses on the interfaces, and all those configurations that you have done manually. Those are saved in the startup config. So and normally that is saved in the NVRAM, non-volatile RAM. So it's gonna load up that also to RAM. Everything is ultimately is loading to the RAM as the computer is booting, router is booting. That's your boot process basically. Okay, so going back, okay, boot process, and there are some commands like boot system command, global configuration command. So the boot environment variable is set using the boot system global configuration command. Shows you an example right here. Boot system is a command. In the flash memory, in this location, you have this file all the way to the bin file C2960. Starting from there, the .bin, that is your Cisco iOS file. Okay, you can use this command to set the boot environment, boot mode. Now show boot, use that command, show boot, to see what the current iOS boot file is set to. You can check that by show boot command. Of course, all the show command must be used from the privileged exec mode. Okay, going next. Recovering from a system crash. Either your system has crashed, that your operating system is no longer booting Cisco switch, or you need to do recover your password. When this kind of situation happens, you're locked out of with your password. You've forgotten your password, or you bought a used router from somebody. They had a password, so now you need to reconfigure it. You need to erase that configuration, get rid of the password, and load your own configuration, set your new password, and things like that. To do that, here are some steps. Number one, connect your PC by a console cable. Of course, we have discussed that in the semester 1 of CCNA. I'm repeating and trying to recap on that, so remind you. So what you do on your console port of the router, you plug in a PC or a laptop. And if I go here to Google, we can type up that Cisco console connection. Okay, and that's going to show us exactly how to do it. We have seen it many times. I'm going to just make sure that I show you again. And so that's what they're saying, that on the Cisco router, you are going to plug in this console cable, and on the other end, you plug into a computer. Like this part, this side is going to go to a computer. And what it looks like once you connect, it looks like this. Okay, right here. So here is my laptop. On the serial port, I plug in one end of the cable. The other end goes all the way to my console port in the back of the switch. Okay, that's just like this, from the laptop to the console port. Okay, once I do that, number two, unplug the switch power cord. So then I basically turn off the switch, take the power off, and then reconnect the power cord. But this time I would reconnect the power cord using also holding the mode button. Okay, Cisco router, Cisco switch has the mode button. Let me show you. Cisco switch, SWITCH. Because I'm trying to do the password recovery, I'm trying to reset the switch. That's why I need to press the mode button. If I didn't have to do that, I would simply just turn on the power and that's it. Just plug in the power cord, the switch boots automatically in a normal situation. Okay, but in this case, I'm trying to reset the router altogether, the switch altogether. Router or switch, same, similar, very similar. In the switch, I have this mode button right here. So I'm going to hold on to press the mode button and keep on holding it. And so I'm going to see this, lights are going to come on green, then finally blinking green, then finally becomes solid green. Okay. So the system LED is still flashing green. Continue pressing the mode button until the system LED turns briefly amber and then solid green. That's when you stop. Once you see that it's from blinking green or sometimes amber, eventually it becomes solid green, then you're done. You can release the mode button. Then the bootloader switch prompt. In this case, normally switch has this kind of pound sign or the greater than sign. For example, I have a switch here, right here, in my packet tracer. See, we have a greater than sign. That is the normal command prompt because I'm in the normal mode. Okay. If I'm in the password recovery mode, it will be a different type of view there. Switch. And if I do go to the enable mode, we know that it has shows a pound sign. So either a pound sign or a greater than sign is normal. But in this case, when you're doing password recovery, then you're doing it switch. It's going to show, your switch is going to show a colon like that. That will be your mode. Okay. You're going to see this kind of prompt, switch prompt. Okay. And then you can actually type commands in the bootloader. You're in the bootloader mode. You're not in the normal mode in this case. So you're going to type up the command, and you can type dir command to see what directories are in there, what files you have, and so on. Okay. So now, dir flash, it shows the content directory of the flash. This kind of command I can use in a normal mode. This person is using the normal mode, dir flash colon. So if I go here in my switch, I type dir flash colon. Okay, it shows that what files are in my flash memory right now. I do have a bin file, okay, in the flash memory. So that's right here. Okay, this whole thing C29 all the way. That's my file. If I go and expand it, then you can see it shows in one line now. All the way from C29, that is my operating system file in this case. It's in the flash. Anyway, let's move on. Now, we need to have some knowledge about the LED lights. The switch has so many LED lights that these light up green, amber, blinking green, all those, we need to understand what they mean. So let's take a look at it. The Catalyst 2960 switch LEDs, for example, LED in a light emitting diode, LED we sometimes just say LED. So these LED lights, number one, we see here the system LED right here, system. So what does the system LED mean? We need to understand that. Okay, the system LED shows whether the system is receiving power. That's it. This is basically your normal power LED. Whether this switch is receiving power and is functioning properly, the hardware is booting, hardware is getting the power and responding. There's nothing wrong with the system itself. That is the system. RPS. RPS is redundant power supply. The second one, redundant power system or redundant power supply, that's the RPS. Many switches have more than one power supply. You can actually, many of the switches, you can plug in more than one power cord. In the back of the switch, there are more than one power cord plug-in interface. So you plug in from the wall one power cord, then from the wall you plug in from the power outlet one more power cord. Yes, there are switches like that. That's more than one power supply connection is there, and it has that for redundant power supply. In case one power supply fails or one power source fails, you got the other power source. That's why. So this is the RPS, redundant power supply LED. This LED shows whether the RPS is off, redundant power supply is off, or is not properly connected. If it is off, and if it is green, then it means that my second power supply or the redundant power supply is connected and providing the backup power. Okay. If it is blinking green, that means it's connected, but there is for some reason it's being unavailable right now. Okay. Now, this state STAT, that is the status. Okay, status LED. The status for the port status LED. This shows, this is actually very general for the port status. Each port, like 1, 2, 3, 4, so many ports should be here on the switch. Those ports are going to have their own, each one of the ports is going to have its own own LEDs, LEDs. for the speed and duplex and all those. This one, the status, that is a very general one for all of them, whether the port status itself is selected or not. That this one shows. So let's go down a little bit to see what it means. Port status LED indicates that port status mode is selected. Okay, so when this light is green, and that is the default mode. If you didn't do any change, by default the port status mode will be selected. When it is selected, then the port LEDs will display colors. If it is selected, then of this, each of this port, like port number 1, port number 2, all these ports, they have their LED. They will be displaying different colors and indicate different things. If the port status itself is turned off, then these individual ports LEDs will not show those colors. That's all. That's what it means. This overall port status is selected or not selected. Next is duplex. It shows whether it's a half duplex or full duplex. If it's off, then half duplex. If it is on, then full duplex. Okay, indicates that port duplex mode is selected. And when the LED is green, when it is selected, the port LEDs are off, are in the half duplex mode. So if the duplexity is selected here, green, then each of these individual ports, like port number 1, port number 2, their duplex light is going to be on or off. Their duplex light is off, meaning half duplex, on, meaning full duplex. Okay. Now, port speed. So port speed right here, speed LED. This is the overall speed. Again, each port has its own speed light as well. Okay. So this one meaning indicates the port speed mode is selected. When selected, the port LEDs will display colors. If this is speed, this LED is green, that means port speed indicator is selected. Then I'm going to look at in each individual ports and look at their colors, and I will know, look at their LED status, and I will know this one port is 10 Mbps or 100 Mbps or what. Each port is going to have its own light. Okay, once that is selected, this is speed. Okay, so now 10 Mbps, if the port is operating at 10 Mbps, its LED is green. If the port is operating at 100 Mbps, it's going to be blinking green. Okay, so sorry. If the port is off, then 10 Mbps. If it is green, then 100 Mbps. And if it is blinking green, then it's 1000 Mbps or gigabit per second. Okay, that is going to be on each port. So don't be confused with this writing here. Each port is going to show its own light, but you have to select that speed, this light first, and by default it is selected. Okay, and power over Ethernet LED, that's going to show your status of the whether you have selected power over Ethernet or not. Okay, so meaning through this Ethernet port the power can go. Power is, can be supplied via network cable. Okay, that. Next, preparing for basic switch management. Okay, as we were saying that a switch would be connected to a PC via a console cable. Okay, so we are seeing here the console cable is used to connect a PC to the console port of a switch for configuration. We know this. To remotely manage a switch, we don't use a console cable because we are far away to New York. Then the switch must be initially configured through the console port. So first time you got to use the console port to assign the IP address and everything, so that next time you can access it from far away from another city via IP address. But that IP address has to be set to the switch first. To do that, initially you have only option, that is to plug in via the console, being physically there. Okay. Next. Okay. Now we're discussing configuring basic switch management access with IPv4. So we are going to configure this switch so that eventually this switch can be remotely accessed. Not always I have to go to the switch and physically plug in a cable. I may be in the next building, or next room or next city or wherever. I want to be able to access this switch via IP address, via its IP address that I configure on it. How do I configure that IP address? That's what it's showing right here. We have done these things before, but we're going to do in more detail in this new course, CCNA 2. On CCNA 1, we had done this. I'm in the switch, configure terminal. Go to the config mode, go to the interface mode, and type an IP address. Okay. For example, here is a switch that I have. Okay. I have a switch. I'm in the privileged exec mode. Okay. In the privileged exec mode, then I'm going to go to the global config mode. I type config. Let's see. Config 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 t. Okay, I mean, oopsie. Oh, config t. Okay, config mode. Then I'm going to go to interface. Do you know what interface gets an IP address for the switch? If you remember, the switch does not get an IP address on its fast Ethernet 1, 2, 3, 4 gigabit Ethernet. None of those ports. Switch does not get an IP address on its physical ports. Switch gets its IP address on a virtual port, not on a physical port, a port that physically does not exist. It is only for accessing the switch remotely. So that like a VLAN, okay? So I'm going to type interface VLAN 1, VLAN 1, okay? I'm in that VLAN. I'm going to type an IP address, say 192.168.1.1, 1.2 per se. 1.1 was my router per se, and 1.2 is my switch. 255.255.255.0. That's my subnet mask. Enter. I got it. Okay. Now no shutdown. No shutdown. So it's gonna be up. So what I did, I went to the interface VLAN 1. In that interface, I assigned an IP address and a subnet mask, and I'm gonna do no shutdown. That command. Enter. Now it's up. Now I also have to assign a default gateway. This switch VLAN 1 interface is having an IP address and it's up now. So now, only one more thing I have to do is to assign a default gateway. But right now I'm going to go to the privileged exec mode and type the show command to see the status of the port. So I'm going to go to end, click, type end. I'm in the privileged exec mode. In this mode, let me type in show command, show IP interface brief, BRIEF. I'm just demonstrating these things to you, and we're going to be doing this in the lab very much. So right now, just go through the overview. You don't have to do it. Just learn right now. See, all these IP addresses, fast Ethernet, they don't get any IP address. Okay, nothing is connected to it. Just I only have a switch by itself. Nothing is connected to it, so they're all down. But look at this one interface, VLAN 1. It is not a physical interface, it's a virtual interface. And that one is, right now, this interface is up. Its line protocol is down because no other router or nothing selected, connected to it in that subnet. That's why. It's not finding any other device with their IP address to communicate with. That's why it shows down right here. So VLAN 1 is up right here, manual and up right there. Okay. So now I'm going to go to this switch now, go to the global config mode again, and assign a default gateway. Go to config T. Okay, config T, and do the default gateway. Default gateway would be IP, just DEF tab, IP default gateway. Say my router's IP address is 192.168.1.1 instead of 2. So 192.168.1.1, and that's it. My default gateway is set as well. Okay. So this is what is needed. Then of course I can copy running config to startup config if I want to save this configuration. We know that. Okay. In this case, in your book right here, they are assigning VLAN 99, but I did it on VLAN 1 because VLAN 1 already exists. VLAN 99, if I want to do, then I have to create that VLAN. So I took a shortcut route. VLAN 1 is there by default in the switch. So I used interface VLAN 1 instead of 99. Okay, next. They configured the IP default gateway because the router is here. So if I were to plug in a router with my switch, here's my switch, and I would like to create a connected router, I could do that. And then it's going to be connected to right here with that default gateway IP address is going to be the router's IP. Okay, I'm not going to do that now. Let's move on to the chapter. Okay. Show IP interface brief, and it shows that VLAN 99. Okay. So that's the kind of command that we did it right here. Show IP interface brief. Shows all the interfaces that I have. Okay. And now it shows in your chapter right here, how do I create a VLAN? I type VLAN and then VLAN ID. That's how we create a VLAN. Then name and then VLAN name. I can do that. Let me show you an example. How do I create a VLAN in a switch? Okay, VLAN and is just a number between 1 to 99. Okay, then a name, just a name without any space inside the name, without any space within the name. Okay, and then the exit. Okay, so I go here. I'm in the config mode. I type VLAN. See, I'm creating. They created a VLAN 99. Let me create a VLAN 99. Okay, I'm going to name it. Name management. Name this VLAN MANAGMENT management. That's the name of the VLAN I want to do. I did that. That's all I have to do to create that VLAN. Okay. Right now, then that VLAN is created now. Okay. And if I go right here, just to show you something real quick, go to the end, press end. I'm in the privileged exec mode. If I type show command and I space, do the question mark, it shows all the show commands are there. Oh, in the show command, I can even use VLAN. Okay, fine. I'm going to use VLAN. And then what can I do? Question mark. Look, I can use show VLAN brief, this command, and it's going to show me some brief information about the VLANs. Show VLAN brief, BRIEF. So it shows me all the VLANs that I have. And look, VLAN 1, that was the default VLAN. I have that as an active VLAN, okay, automatically. Look at this VLAN 99, that's the management. That's the one I created. So I just wanted to show you that VLAN 99, see? If I create more VLANs, VLAN 30, VLAN 31, VLAN 12, anything I want, between 1 to 99, I can create all in here, okay? Okay, next going. Okay, next, duplex communication. We have discussed about it that a port can be half duplex or full duplex. If a port is half duplex, it can only send or receive at one time. It could not send and receive at the same time, two-way communication. It's going to be only one-way communication. And if you remember in the class, I told you about the example of a walkie-talkie, that only one person talks and says over, only then the other person can talk. On the other hand, that's a half duplex. On the other hand, when we are talking on our cell phone, both parties are talking at the same time, screaming at each other at the same time. They all can hear at the same time, both inbound and outbound. Okay, in and out, send and receive at the same time. That's a full duplex communication, an example of full duplex communication. Okay, so there are switch ports that can be set as a full duplex port or as a half duplex port. Okay, of course we're going to prefer all the full duplex. Look at the gigabit Ethernet, 10 GB NICs require full duplex connections to operate. For the newer connections, faster connections, they more require full duplex. Okay, full duplex is much better because you have 100 times 100% of its bandwidth is available. As opposed to a half duplex, you only have 50 to 60% of the bandwidth is available because only half the time it can send and half the time it can receive. So we want full duplex. Next. Now duplex and speed on a switch port, on a specific port on the switch, I can actually configure its duplexity and speed. I can configure it to be a full duplex. I can configure it to be half duplex. I can set the speed 100 Mbps or 1000 Mbps or 10 Mbps. We can do that. Okay, all I have to do is this command. Duplex is a command, speed is a command. We do that in the interface mode. Just showing an example. So I go here just to show you as an example. I'm in the privileged exec mode. I'm going to go to the global config mode first. So I can type config T, config mode. Okay. I'm going to go to a particular interface. See right here, so many ports. One of the port is what? Fast Ethernet 01. Let me use the Fast Ethernet 01, that port. So I'm going to type interface Fast Ethernet 01. I'm in the interface mode. Whatever I type here, that will apply to this port only. Okay. So now I'm going to type duplex, DUPL tab. See duplex. What are my options in the duplex? I do the question mark, and I see, oh, I have three options: auto and full and half. So I can set it as a full duplex or half duplex or auto. I'm going to go ahead and send full. I'm going to say I'm going to send to auto, AUTO. So it's going to automatically negotiate and sense on the other side, other device that is connected to, whether a full duplex connection can be established. If both sides of the cable has a full duplex port, so then automatically they're going to negotiate to make it full duplex connection. Okay, auto. How about the speed? SPEE tab. See speed. What are my choices here? Let me type a question mark. Oh, I have three choices here. I can do 10 in this case. I can do 100, and I can do auto. Okay, so this one is not a gigabit Ethernet. This 2960 switch, it only supporting in here, in this case, only up to 100, not 1000. Okay, so I have three options in here. I'm going to set it to auto also, this one, so it can automatically negotiate the right speed. Okay, that kind of thing. So if I want to get out of here in one jump and go to the privileged exec mode, I will set I will type end, END. Okay, going back. Now they're asking you to practice. So I want you to practice. You can click on the show me. It's going to show you how to go there and show me and practice. Okay. Next. MDIX. Okay. MDIX stands for this medium dependent interface crossover. Okay. That's what it stands for. Medium dependent interface crossover. X means crossover. Okay. So what it means, let me explain to you. What is MDIX? In the past, look at these two switch, S1 and S2 in. Okay, what cable do I need to use? What type of cable? You say, well, Ethernet cable. How about between the PC1 and the S1? What type of cable do I use? Ethernet cable. But Ethernet cables can be different types. Can be straight through or crossover. From a PC to a switch, I should be using a straight through cable. And between two switches, switch to switch, I need to use a crossover cable. Okay. Then again, from this switch to another PC should be straight through. So you've got to have the right kind of cable what you're connecting, either a straight through or crossover. Between two PCs, if you say that, okay, can I connect actually from this PC directly to the other PC without a switch? Yes, you could. Just from only, if you're using only two PCs for a network, You don't even need a switch in the middle. You could just connect from PC to the PC directly. What kind of cable do you need in that case? A crossover cable. Okay. So now Cisco has this new feature, new command, new feature in the port. If you set that MDIX, auto MDIX, then you don't have to worry about what type of cable you're using. You can simply use a straight through cable all over, no problem. You can just use a straight through cable as long as between the Cisco devices, as long as auto MDIS is enabled. So the switch and the router automatically find out that, okay, I have a crossover cable. I know I can use that. I know how to adjust myself to use that crossover cable. Or I have a straight through cable. It's okay. Whatever cable you give me, it's okay. I can automatically adjust my communication with that cable. Isn't that cool? So MDIX is a good thing. Okay. So here MDIX is a command you can set to be auto. So all I do, go here and global config mode, config T. I want to go to the interface fast Ethernet 01 per se. I mean that interface. I can type MDIX, just type MD tab, okay, and set that to auto, AU, auto. That's what I do. All I did, I went to the interface and I type MDIX auto. That way, any type of cable is okay. My switch can automatically adjust to that cable, okay? So that's it. They're asking you to practice the command, practice that at home. Okay. So that's it. Okay. Now verifying switch port configuration. Anytime we talk about verification, that means show commands. You want to show and see how you have configured, how it is configured right now. Show interfaces, show startup config, show running config, show flash, show version, show history, show IP and IP interface ID. Okay, so all of this kind of commands. Show MAC address table, show MAC address table. Okay, either with a hyphen or without the hyphen, it's all okay. So these kind of commands you use as show commands. Okay, and it shows why do you use them. Display current startup configuration, of course, show startup config. Display current operating configuration, running config, show running config. Display information about the flash file system, show flash. Okay, display the hardware. Okay, like what kind of processor, what kind of operating system you're using, how much RAM, show version. Display history of commands that has been entered in this. You type show history. So if I type here show history, I'm going to go to the end to go to the global privileged exec mode, type show history, enter. These are the commands I have so far used in here, showing all the commands. Okay, show history, things like that, and show MAC address table. These kind of commands are there. So we are familiar with the show commands. Okay, next, network access layer issues. Okay, remember what is a network access layer? You may say, hey, network access layer, what is that? We know physical layer, data link layer, network, transport, then session, presentation, and application layer. What is network access layer? Network access layer is in the TCP/IP model. Remember, TCP/IP model only has 4 layers. OSI model has 7 layers, and they are physical, data link, network, transport, session, presentation, application. On the other hand, on the TCP/IP layer, you only have 4 layers, and there the bottom layer is network access layer, and then you have internet layer, then you have transport layer, and then you have application layer. Only 4 layers. So this network access layer, it has let me see if I can even show you a picture just to remind you. OSI versus TCP/IP layers. Okay. So here I have these two. Look at that. Here is my OSI model layer, 7 layers, and here is my TCP/IP model. Yes, it only has 4 layers in there. Network, not a network interface. That's wrong. Network access layer should be network access layer. Okay, network access layer, and then internet layer, transport layer, and application layer. So this network access layer of TCP/IP includes both physical and data link layer. Just remember that. So that's the network access layer. Okay. So here in this network access layer, I'm talking about physical and data link layer. Now, when you see show interface fast Ethernet 0, 1, if you do if you type this kind of show commands, you see that the fast Ethernet 0, 1 is up, line protocol is up. Okay, I can type this kind of command right now. Mine is going to be down, down, but let me show you. Okay, show interfaces FA01. I'm here in the global config mode. I type show, just int, then tab interfaces fast Ethernet 0, 1. It shows about this one particular interface. Okay, only shows because I only ask for this one interface, fast Ethernet 0, 1. What does it show? Fast Ethernet is down, line protocol is down. So, oh my lord, it's down, down. Okay, why is twice? Why this one says down and the line protocol is down? What does that mean? What do they mean? That's what we're teaching you here. Look at this. Interface status up, line protocol up, to up, up. In my case, was it down, down, right? So up, up means it's operational. Down, down means interface problem. But then you may say, why down and down twice? The first one means your physical connectivity. So my port, in my case, in my switch, port number 1, nothing is connected on the switch. Okay, if I go to the port number 1, connect a PC, then it's going to become up. Okay. For example, say I go here right now and get a PC. Get a PC, put a PC in here, and I have this copper wire straight through. Connect here, fast Ethernet, connect here, say fast Ethernet 0, 1. Once I connect, it's going to take a little bit of time, but they become green. Then my interface is going to be up. Okay, I can fast forward the time. Okay, now I go back to the switch. Now I go back to the switch. See, the fast Ethernet 0, 1 changed the status to up. See, and I can do right now. I'm going to type show interfaces fast Ethernet 0/1, and now it shows. Look, now it shows fast Ethernet 0, 1 is up, the line protocol is up, is connected. See, so now you understand what it means. Okay, so in my case, and now it is up and up. Okay, meaning the actual physical connection is up, and also my software wise the connectivity, like the duplex city has no problem, speed has no problem. If there's a mismatch between duplexity, then the second one is going to be down. It is physically connected, so the first one is going to be up, but line protocol would be down because I have a mismatch in my duplex, for example. Okay, so here are some explanations. Just read in the detail. Okay, show interfaces command. If I do show interfaces, I'm going to show this kind of run frames, giants, CRC. You say, what are they talking about? Let me show you what we're talking about. If I type show interface, which I did right here, okay, and see so much information is showing in here. Somewhere I'm going to see all of those things. Look at this: CRC, 0 CRC, 0 runs, RUNT, 0 giants. Okay, all kind of way too much information because I typed this command show interfaces 0, 1 about this one particular interface, showing what kind of communication is taking place. Look at my bandwidth. This is a 1 million kbps, meaning let's see, meaning 10 well, let's see, K meaning 1000, so it's gonna be 100 Mbps. Okay, 100 megabits per second. That's what it is. So you take 3 zeros out, that's 100 mega, 100 million, 100 Mbps. So it's a fast Ethernet. Okay, both ways. And so speed was good. Look at here, shows right here. It's a full duplex connection right now, and 100 Mbps, which I said already. Okay, then shows what kind of errors is having. It says 0 input errors, no errors. That's why CRC meaning cyclic redundancy check, no errors. 0 frame, no communication has been happened yet. Okay. Round means very small size frames. It's a fragment. It's bad frames. Giant means bigger than the frame size. So nothing of those sort happened. Okay. Now it's showing. Now you understand what I'm talking about. So when we do show interfaces, then we can see this information. That if it's a round frame, let's see. Let's look at this right here. Look at this. Input errors. Total number of errors. Rounds means packets that are discarded because they are too small. Okay. Giants. So the round was smaller than 64 bytes. Giants is like bigger than 1518 bytes. Like a really large Ethernet frame. Okay. CRC, cyclic redundancy check. How many CRC errors happens? So these kind of things will be showing in there with the show command. Okay. So that's why show interfaces with that command, you will be seeing this kind of information. Next. Okay. If you're doing troubleshooting, okay, if you're doing troubleshooting your interface, that your fast Ethernet interface 01 or 05, whatever, it's not working, then you go to the show interfaces command. Does it show the interfaces up? Yes, it shows interfaces up. That means your physical connectivity is okay. Maybe your duplexity is not set correctly. Maybe you are having some interference in the communication, like EMI, electromagnetic interference, or line is too noisy. Okay, something is happening, some kind of interference is happening in your cabling, wiring, in your environment. If the interface is not up, then you check the cables are connected with the PC or not. Things like that. Okay, so it just shows that how do you do troubleshooting. Okay, once you have done whatever in this step is done, put the cable back on, or set the duplex properly, then you go to the next step. Is the problem solved? Yes, we're done. Problem is not solved, you escalate to your bigger interface network admin guy. They are going to find out what needs to be done. Okay, so that's what it shows right here. Next. Now we talk about SSH, secured shell. We have done this many times. Here is a screenshot from an Wireshark, okay, telnet capture. Using the Wireshark, you can actually capture some packets as they are traveling through the network. Okay, and telnet is insecure. Telnet is an insecure protocol. When you are communicating via telnet, why do we use telnet for? Say your router or switch is in Dallas and you are in New York. You want to connect all the way from New York to Dallas. So you can either use telnet or you can use SSH. If you're using telnet, you're using the password and your username. So those are all seeable. If somebody would be capturing this packet via Wireshark, he can see your password because it's not encrypted. That's why we like the SSH. We don't like telnet anymore. We want to have secured connectivity. Okay. So always remember that the port number 22, SSH uses port 22, and TCP uses port 23. So these days we don't use telnet as much anymore because it is insecure. It is not encrypted, and SSH communication is encrypted, so it's more secure. Okay. So anyway, so showing the password, everything in plain text, but when it's encrypted, then nobody can understand the password. Even if they capture, so much encrypted, no way to understand the password. Okay, now whether your switch supports the SSH version 2 or not, how do you know? Your operating system in the switch, if it has this characters K9, that means it does support the SSH version 2. SSH version 2, it supports K9. Let's look for in the operating system. If you type show version, see if I go right here, I'm in the switch. I'm going to type the command show show version ver tab enter. Okay, that's my whole command, whole output for this command. Where is my operating system? How do I find that K9? Here is what I type the command, and here's the whole output is showing. Okay, so I make it a little bigger, wider, okay, just to make sure, and I'm gonna see somewhere that file K9 would be there. Okay, let's see, let's keep on looking at software version. WS, let's see. Sometimes in the packet tracer, it's hard for us to find out. It does not show as easily as in a real equipment. Okay, so this is the revision number. Okay, C29, that's ROM. This is our Cisco. What kind of router? That shows right here. This is the memory. It shows there, RAM. Okay, show version should show us that what kind of operating system we had. Somewhere it's going to show K9, and I don't see it in here, unfortunately. I was not able to locate that. Okay, if I do show SHOW flash, okay, that should show. Okay, C29, that's my whole operating system. So in this case, it is not showing my if it is not showing K9 in the operating system, it's going to show .bin. Okay, bin file. I don't see it here. Okay, so it's very unusual that it's not showing a .bin file in there. That's the operating system. Okay, right here, this is .bin, like I showed in the show flash, but it's not showing the K9, so it will not support the version 2. Okay, I was able to show you this .bin file. That .bin file should have been shown in the show version command somewhere. Okay, that is my operating system, and that operating system does not have the K9, then it does not support the version 2 of the SSH. That's all I was going to show you. Okay, so now show version command on a switch to see iOS switch is currently running an iOS file name that includes the K9. In my case, it's not K9, so it does not show. Okay, so I won't be able to do the cryptographic features capabilities on that. So let's go to next. Well, why don't I show you something else? Let me see something else in here. Let me do a router that may have a new version, different version of the operating system. Okay, I go to right here, go to the router, say 1941 router. I plug in a router right here. Okay, this router, I'm going to show you the K9 if it supports the version 2. Let's see. No, Okay, enable and then show ver version. Okay, look at that. This one shows a K9. That's exactly what I wanted to show you, my friends. Okay, I did a show version on this router, not on the switch. Switch was, it was a 1900 switch, a 2960 switch. It did not support, but this one does. This router does support. Look at here, it has this K9 right here. That's the operating system. .bin file. Right here is the K9. Okay, so this router is gonna support SSH version 2. Okay, just to make sure that we understand what I'm talking about. Okay, all this. Okay, wonderful. Go back. So going back to the chapter all these things we have gone through. Next, okay, configuring SSH. How do you configure SSH on a router or a switch? Okay, let's do that. Okay, we can configure the SSH by configuring a few things. We first type a domain name, IP domain name, crypto key generate. We have done this. We've done this in the several times in the first semester in CCNA 1. It's just a repeat for us. Okay, we are gonna configure an IP domain name first. Then generate the RSA key. We type crypto key generate RSA. We have done that. Then we have done let's see, a username and password. Configure a username and password. Username and then secret, whatever the password is. Then configure the VTY lines, virtual terminal lines, and enable the version 2. Okay, so that's the thing I was talking about, the K9. Okay, so now here's our practice. Okay, set the domain name to cisco.com and generate the 1024-bit RSA key. I don't like to do it here. I'm going to do it in this switch right here. Domain name would be cisco.com. So I go to the switch, for example, here. I'm going to have to go to the global config mode. Config T, I'm in the config T. Okay, I type domain name. I'm going to type IP DOMAIN domain name. Okay, CCNA or cisco.com. Cisco.com. My domain name is done. I'm going to type cryptographic. I'm going to generate cryptographic key. So I type crypto, CRIP, okay, crypto, just key, generate, crypto key generate, RSA, enter. Okay, please define a host name. Okay, we have not done a host name, that's why it didn't allow me. So I'm going to type a host name first. Say host name, this one, this switch has a name. I'm going to type say S1. Okay, now I'm going to type the same key, the crypto key. That's that command. I just did up arrow key to bring the same command up. So now it's allowing me, telling me how many bits do you want. 1024-bit key. Enter. That's done. Okay. So now SSH 1.99 has been enabled. It does not support 2.0. SSH version 2 it does not support, but I was able to do SSH a earlier version, okay, an earlier version of it. So that's what I can do. Show all right here. It shows how to do that. Okay, this crypto key generate, that command, domain name cisco.com. These are the two commands I have done so far. Okay, and it worked. So 1024-bit key as I did. And then you go to the line VTY, do transport input SSH, login local and N. Okay, I do need to create a local username and password first, like username admin secret CCNA. Okay, I'll do that. Create a local username and password. Okay, username admin and password CCNA. Good. So this is the router. I don't need the router. I want to go to the switch. Okay, I'm going to type username, create a username. So what username is this for? This username is for remotely logging in using the SSH from another city, another place, okay, from far away. Now username admin, oopsie, admin, and secret. Secret is the encrypted password, CCNA. Okay, enter. I have done that. After that, I can go to the VTY if I want. I can type line VTY 0 to 15, and I type transport. We have done these things, and we're going to do more in the labs, so don't worry too much. You all are going to have to do that, practice that in the labs. Transport, input, okay. Either I can do SSH or telnet or both. I can do, in this case, just SSH, okay. Then I can do login local, so that next time when I want to log in remotely, this local username and password that I created, username admin, password secret, only that username will be used for that. Login local, enter. Okay, all of those are done, and then I can just exit out of there. Now my SSH is configured. Okay, next, verifying the SSH. Okay, SSH is enabled on the S1. So how do you verify it? Okay, so show IP SSH, that's the command. Okay, just remember that, show IP SSH. Okay, let me see if they're going to use that. Okay, login as, okay, very good, show IP SSH. So I'm going to type this command right here. I'm in the config mode. I don't type show commands in the config mode. I go to exit. I'm in the privileged exit mode. Show IP SSH. Okay, it shows SSH enabled. See? Okay. Now, next. Now, secure unused ports. Now, what are we talking about here? What does that mean? What happens in a switch? Say you have so many fast Ethernet ports. Okay, let's look at a picture of a switch here. Cisco, say 2960. Okay, that switch. Let's look at this. Look at this picture. So I only have two computers plugged in with this switch, port number 1 and port number 2 per se. That's it. Now, all other ports are remaining. Say, what if somebody, a bad guy, walks in and plugs in his laptop into one of those ports? It's going to work just automatically. It's all ready to work, and he can connect with my network. But you know what I can do? I can disable all other ports. I can disable all other ports. Then you may say, so that if anybody comes in and plugs into an available port, it's not going to work. Those ports are disabled. He has to go into the switch and have the password to be able to access the switch, and then reconfigure and open up these ports. They can, so I can disable those ports administratively, shut down the ports. Then you may say, well, what about this? These two ports that we plugged in, our PCs, that guy is going to come, unplug this one, and plug his into this port. This port is enabled. This port is working, not shut down. Then what can I do in that case? We can actually configure these ports, these two ports that I have my computers plugged in. I can have those ports only accept the MAC addresses of my PCs, not the bad guy's PC. Okay, so I can restrict these ports to only allow certain MAC addresses. Those are part of the port security. Okay, so we're gonna talk about those things now. Now, coming back, first we're talking about how to secure the unused ports, the ports that are not being used. Those ports I can just disable them. How do I disable them? Just use the shutdown command. Easy peasy, lemon squeezy. Okay, very easy. So all you have to do, just use the shutdown command. That's it. So interface range, for example. And am I going to go like each one by one port and keep on typing shutdown? No. I can just go to select a range of ports and shut down all of them. For example, For me, right here, this one is on fast Ethernet 0 1. Okay, I plugged in, and I would like to say shut down all other ports. Only the one port I have, fast Ethernet 0 1, I have something plugged in, and I have up to fast Ethernet 0 24 ports in this case, and gigabit 0 1 and gigabit 0 2. Let's shut down all of them. I can do that. I can go to the switch. Say I'm going to be keeping the gigabit for to connecting the routers. Okay, I'm going to only shut down the fast Ethernet ports other than the port number 1. So what I do, config. Okay, CONFIG T config. I'm in the global config mode. So let me go do the interface mode. Interface fast Ethernet. Oh, in this case, I'm going to choose interface range. RAN tab interface range. Say fast Ethernet 02 to all the way to 24. That many. Only the one I have it enabled. From 2 to 24, I would like to disable them all. Enter. See, this whole range is selected. All I have to do, shut down. That's it. All those ports are now down. See, administratively down. Every port is now administratively down. So that way, if anybody comes in and plugs in their PCs or their device to those ports are not going to work. Okay. Next, port security operation. Okay. Then there are other things we can talk about. Secure the MAC address types. Remember I talked about that I can set a port to accept only a number of MAC addresses. I can say accept only 2 MAC addresses. Sometimes I use this PC or the other PC. Only mine, two of my own MAC addresses, no others. Okay. I can do like 10 MAC addresses only from my company. I can do that. I can assign this port to accept only 1 MAC address if I want to do that. Okay. So those are all part of the port security. So Swiss port security, then MAC address. Okay, that's the command I do. If it's a static, secure MAC address. If I want to say a particular MAC address, then what I have to do, I type this command: Swiss port, then and then type MAC address, and then the actual MAC address of the PC. Okay. If it's a dynamic MAC address, then I don't have to actually specify the MAC address. It's gonna be, normally we put it as sticky. Sticky means computer is gonna automatically learn. Whenever first time I plug in my own PC, computer is gonna learn that MAC address, and after that it's gonna only accept that MAC address. If I say only 2, then the first 2. After that, no other MAC address will be accepted. Okay. So that's called a sticky MAC address. Sticky means learn automatically, first time plugged in, and then keep that in the memory. Okay. So we type this command: Swiss port, then port security, then MAC address is sticky. Okay. And that these kind of commands are used in there. Okay. Let me show you an example. Say in my situation, that way you can actually find understand better. Here, I'm gonna type exit first of all. Here, I'm in the global config mode. Okay, I would like to select this port number 1. Port number 1 right here. My PC is connected. On that one, this PC has a MAC address, right? I would like my switch to learn that MAC address automatically and keep that in mind, put in the memory, and only accept that MAC address. Okay, that kind of configuration I would like to do. I'm going to go to the switch, interface, fast Ethernet 01. That port is selected. Okay, I can type, first I have to type Swiss port. Okay. Okay, Swiss port. Normally switch, then SW Swiss port. then PORT, port security. Let me tell you what's happening here. Swissport port security, that should work. Swissport port security, that should work until, oh, Swissport port security, that you do in the global config mode. In the, no, so it will not work until ports are enabled. In interface, yeah, it is on the interface. It is on the interface, but let me see what's happening here. Swissport, for some reason, I'm in the interface mode. Normally it should take. Let me show you what commands are available. Okay, CDP Swissport, yeah, that command is available. Okay, that command is available. SWIT, there you go. I was probably wrong, mistyping. Okay, okay, SWI, look, Swissport comes up. Then port security, just port security, see, easy. Swissport port security, if you just type just that much and you press enter, then what happens? The Swissport port security is enabled. Okay, it's a dynamic port. So Swissport port security, that this time the command is rejected because it's being a dynamic port. Okay, Swissport port security, and then you put this command right here. Normally, MAC address sticky. Okay, MAC address. See, MAC address, you can put maximum number of MAC address like M. MAC address sticky, STICKY. Okay, that. Swissport port address, port security, MAC address is sticky. This is the command they're showing you right here. Okay, that means automatically dynamically learn the MAC address and then keep that in the memory. Okay, sticky right here. Okay, sticky right here. Okay, that will do that for you. Okay, so this is what we learned from here. Going to the command, that's a Swissport port security, MAC address is sticky if we're doing it dynamically. Otherwise, I would do MAC address, and instead of sticky, I could actually type up a MAC address. And let me show you how you understand what are your options. Here, if you type this much, Swissport port security, MAC address, then what do I type after that? What are my options? Type a question mark. And you see, you could use a hardware address, actual MAC address you can type up. Then only that MAC address will be allowed. And if you type sticky, then configure the dynamic secure address as a sticky. See? So automatically it's going to learn one or the other. Next. Okay. So what happens when a violation happens? The Swissport port security, in that command, you have put sticky, so your Swiss has learned what MAC address should be allowed, and no other MAC address is going to allow. Okay. Now a bad guy came and he unplugged your computer and plugged in his laptop and tried to get in. What's going to happen if violation happens? You can set it in one of the three modes, either protect mode or restrict or shutdown. Okay, so in the protect mode, what happens? Discards offending traffic, no. Sends syslog message, no. Increase violation counter, no. Okay, so you want to set it. Okay, when the number of secure MAC address, okay, look, okay, now there is no notification that a security violation has happened. If you keep it in the protect mode, there is no message going to come to you that, hey, a violation happened. Okay, the port is not going to be shut down. The traffic is not going to be discarded. You want to set it in the restrict mode. If you do that, then here's what's going to happen. It's going to show you a message. Okay, sends a syslog message. If a bad guy comes, tries to violate, then of course his packet will be discarded. He will not be able to do it, and then in the counter it's going to show that number of violation happens. 5 violation happens. It's going to show that number is going to increase. and you're going to get a message. If you make it in the shutdown mode, then what's going to happen? The port will be shut down afterwards. Nobody can use that port anymore until you come and administratively again do no shutdown. Okay. And what is the command to use? You type Swissport port security violation. Let me show you how to configure that. Swissport port security violation. So here's the command that I type. Swissport, okay, port security. I don't know why before it is not working, but now it's working. Port security, then violation. See violation? Now, what are my options after that? Question mark. Oh, I can do protect, I can do restrict, and I can do shutdown. Okay. If I do restrict, that's the most common one people do. Restrict, enter. Okay. So any violation happens, you will receive a message in your system log that hey, violation has happened, and the bad guy will, first of all, bad guy will not be able to use it. Okay. It's not gonna take bad guy's message. It's not gonna forward. And number two, you're going to get a syslog message. Okay. Okay. Now, how do you configure the port security? Also, you do the maximum number of secure MAC address. Okay, you do that. How many MAC address it should allow? Okay. So Swissport mode access, then Swissport port security. You first put the mode as the access mode. Okay. Swissport mode access, Swissport port security, you got to do that, and then maximum 10. Okay, so look, I'm here in the fast Ethernet 01 on that one. Swissport, I just type SWI and press tab, becomes Swissport. Okay, Swissport mode, just access. Okay, enter. Then Swissport port security, enter, worked. Okay, because I now I set the mode to access mode, so now it takes the command, and then Swissport port security maximum, say I would say maximum just 1, so only my PC, only 1 MAC address, that's it, maximum 1. Okay, I can do that. And then other ones things I have done already. Yeah, all good. That's the only command. The violation, MAC address is sticky. I already have done those things for you. So next, verify. Okay, show port security interface ID command. Show port security interface. You can do that. Okay. Look at what was the command here. Look, show port security interface fast Ethernet 018. Okay, if I do that, show port security interface, I go right here, I'm going to go to end. Okay, show port security interface fast Ethernet 01. I would like to see port security information that I set. Enter. Now it shows, look, port security is enabled. Okay, violation mode, restrict, I chose. Okay, and last address, MAC address VLAN is 0000, has not been set. Okay, so this is your command that you use, show port security, and then whatever the interface you want to see. Okay, that's your command. That's what they're teaching you. Okay, enter. Next. Okay, ports in error disabled state. If it happens that the ports become shut down, then it's going to show the status of the port as the error shutdown, error disabled, like that. Then how do you enable it again? What you have to do, you go shut down that port and then again do no shutdown. 2 steps you have to do. Okay, first you do shutdown and then you do no shutdown. Okay, fast Ethernet. So these people first did shutdown right here and then do no shutdown. If ever a bad guy comes or some whatever violation happens, your port gets disabled, then you come and manually shut it down again, and then again do no shutdown, and it's gonna come up. Okay, next. And looks like all the labs. Okay, that's pretty much it. So for right now, for the chapter 5, it's just some configuring the switch ports. I'm sure we're gonna have labs on the chapter 5. That's why I'm doing chapter 5 first. And the labs are, let's see, what are the chapter 5 labs? Assignment. Okay, I have 5.2.2.7, 5.3.1.2. So 2 labs in the chapter 5. So I should be able to do those tomorrow, both labs. Okay, tomorrow would be Tuesday. I'm gonna again go live. I plan to go live tomorrow Tuesday and do these 2 labs. So come back tomorrow to get those labs with me done. So let's see, at this time, so I hope that everything is going good, and I'll be looking forward to see you all tomorrow. Okay, thank you so much.